Okay, so Malus Law. Malus Law describe the variation of intensity with angle. Okay, so how we can derive the Malus Law, we are going to discuss it today. Okay, so this is the Malus, scientist, one of the scientists. I don't know how to pronounce his name. Louis Malus. Okay, born on 1775, died 1812. Died at very young age, 36. Okay, from Paris, and he is well known for polarization of light, especially special in Malus Law. Okay, so yesterday also we discussed about the filter. Okay, so we're going to use 2 or 3 filters only for your level. Okay, so for the first filter here, coming towards the filter is the unpolarized light. Okay, pass through this polarizer, the first filter. So the intensity is reduced to 50%. Okay, whatever the angle of the filter is. Okay, so this is the first filter or polarizer. Okay, so coming out from this filter, the intensity reduced to 50%, or if the intensity for the unpolarized light is I naught, so coming out here will be half I naught. Okay, that is what is meant by 50%. Okay, for the second diagram, we have another filter. Usually we call this analyzer after the first filter. Okay, so 2 filter parallel to each other. If the alignment is the same, means this is vertical. The first filter also vertical. So all of the light polarized by the first filter is transmitted by the second one. So that's mean the intensity coming out of the light coming out from the filter is the same. Okay, if their alignment is the same, vertical, and the first also vertical. So if the second filter just now, okay, is inclined at a certain angle here. Okay, look at the line here. They are not same, alignment not same. Let's say 25 degrees or 30 degrees from the vertical. Okay, so not this one, this one first. But never mind lah, we discuss the third one. So if the 2 filters are at certain angle to each other, so only some of the light polarized, okay, by the first filter. And if they are aligned 90 degrees or perpendicular to each other, one is vertical, the first filter is vertical, the second one is horizontal. So none of the light polarized by the first filter. Okay. Then this is what we've discussed yesterday. So continue today. We are going to use that for Malus Law. So what is Malus Law? Malus Law states that the intensity of plane polarized light that passes through an analyzer varies as the square of the cosine of the angle between the plane of the polarizer and the transmission axis of the analyzer. So given by this equation, I equals to I naught cos squared theta. Okay, so I is the intensity after the light after passing through the analyzer. Okay, analyzer is the second filter. So this is analyzer, this is polarizer. So if the before the analyzer, the I is I naught. So after the after the analyzer, okay, it becomes I naught cos squared theta. Okay, so the intensity becomes I naught cos squared theta. Okay, so students always confuse, okay, between these two, okay, between these two. So it depends on the initial I. This I naught depends on the initial I passing through the polarizer. So if the first one we discuss, if this is the analyzer and the behind or before the analyzer, the intensity of the light is I naught, then after the analyzer, the intensity becomes I naught cos squared theta. But if the I naught is given before the polarizer, so that means start from the unpolarized light. Okay, if the unpolarized light has intensity I naught, after the polarizer, it's become half of I naught. This one we discussed earlier in the first slide. So if unpolarized light pass to a first filter or polarizer, it becomes half I naught or 50%. The intensity decrease to 50%. And then after it pass through the analyzer, the second filter, then the intensity here, if we use this equation, this I naught is I naught per 2. So we must use this intensity, okay? So the intensity here is I naught per 2. So that's why we substitute here is I naught per 2. So cos squared theta, don't forget. Okay? So students make mistake always when come to this part. Okay, so be careful where the I naught is and what is this I naught means. Okay, this I naught means the intensity of the light before pass through the filter, whatever the filter is. Okay, analyzer or the third filter, the fourth filter, and so on. Okay, so any question on this? Understand, Okay. So we go to the next slide. We are going to derive Malus Law. Okay, we start from the definition for intensity. So intensity is power per area. Okay, we discussed this in the chapter of sound wave. Intensity equals to power per area. So that means intensity is directly proportional to power. And power also directly proportional to energy because power is rate of change of energy. So intensity also directly proportional to energy. Okay, then how energy relate to the amplitude of the wave. So from the first chapter we've discussed energy E of a vibrating mass is given by half m a squared omega squared. Okay, so this is energy, this is amplitude. Okay, amplitude of the wave. So half m a squared omega squared. So that means energy also directly proportional to the amplitude squared. Okay, next, from the diagram just now, before the light pass through the analyzer, okay, so let's say the I is I naught, okay, I naught, and then the A is we present as A lah, okay, so this is I and A before passing through the analyzer. So this become the first equation. Okay, I naught is directly proportional to amplitude squared. Okay, next for the second equation where the light pass through the analyzer. Okay, the I becomes we use as I, just I. Okay, we are going to determine this I. Okay, and then the amplitude decrease to A prime. Okay, so we just write as A prime. Then don't forget the square because the equations come from here. The relationship between intensity and amplitude. Okay, intensity is directly proportional to amplitude squared. So we just write A prime. Okay, then what is A prime? Okay, so A prime is A cos theta. So the amplitude decrease to A cos theta. So we resolve the component of A after pass through the analyzer. Okay, so the initial A after pass through the analyzer. So the amplitude of the wave resolved into two components using trigonometric ratio, the Soh-Chahtua, okay, trigonometric ratio. So it will resolve into two components, A cos theta and A sin theta, depends on the theta. So we choose the A cos theta, okay, A cos theta. So the A cos theta is the amplitude of the light that pass through after passing through the analyzer. So we write as A cos theta. Okay. Then we substitute into here. We expand the bracket, become A squared cos squared theta. Okay, now we substitute the equation 1 into equation 2, where A squared is equals to I naught. So we substitute into here. A squared is I naught. Then we put the equal sign here. Okay, from experiment. So the constant value is 1. Constant value is 1. So we get I equals to I naught cos squared theta. So this is the Malus law. Okay. So done. We have discussed. This is the derivation of Malus law. Okay. So any question with this Malus law? Derivation of Malus law? No, Okay, so instead of amplitude, okay, some books also discuss on the electric field resolved into two components here also. Okay, because the light is a vibration of electric field and magnetic field. So by referring to the plane polarization, we refer only into the magnetic field. Okay, so the we refer only into the electric field. So the electric field after pass through the analyzer also resolve into two components. Okay, E cos psi, and E sin psi. So in this case, E cos psi, okay. Okay, for the polarizer, the first filter here, okay, so the I naught pass through the polarizer becomes half I naught. Okay, given by this distribution, but we are not going to discuss this in detail lah. So we just know that after pass through the polarizer, it becomes half I naught. So you've learned this in this distribution in statistics, right? In the maths T. Okay, so intensity of the light reduced by half after passing through the polarizer, the first filter. From unpolarized light, okay, pass to the polarizer, it becomes half I naught or 50%, reduced to 50% the intensity. Okay, okay, next. So for the graph, I equals to I naught cos squared theta will give you the cosine graph, and it's always positive value because it's a square. So always positive value and it's double for 360 degrees. So the graph is double. Okay, this is one wave, this is second wave. So it's double. So you've learned this in form 4, form 5 already, how to sketch the graph of cosine graph. Okay. Okay, so we will prove this later when we go back to the our actual class lah at our school. Okay, we have polarizer there. We can do a simple experiment to prove this. Okay, so polarization applications. We just know in general, you can Google yourself later. But generally, the polarization is used in sunglasses to reduce the glare. And then polarized filters used in plastic industries, okay, for performing stress analysis tests. Also, the three-dimensional movies are produced and shown with the help of polarization. Okay, then polarization is used for differentiating between transverse and longitudinal waves. And infrared spectroscopies also use polarization. In seismology, okay, we use polarization to study earthquakes. And lastly, in chemistry, the chirality of organic compounds is tested using polarization techniques. Okay, so this is some of the application on polarization. Okay, so we've done the Malus Law. So it's time to show you a few example. Okay, so after this, you can do the checkpoint. So first example, a sheet of Polaroid is being used to reduce the intensity of a beam of polarized light. What angle should the transmission axis of the Polaroid make with the plane of polarization of the beam in order to reduce the intensity of the beam by 50%? Okay, so the solution is, so we use Malus Law. Okay, I equals to I naught cos squared theta. And we assume that before the pass to the Polaroid, okay, the intensity is I naught. Okay, then we are going to get the angle. The angle. We are going to get the angle. Okay, for the intensity becomes half 50%. So half 50% means half of I naught. Okay, so this is to imagine. Okay, so let's say this is the Polaroid. So let's say here is I naught. So we are going to discuss, we are going to find the angle theta here. Okay, for the intensity becomes half 50% of the I naught. So 50% of the I naught means half I naught. Okay, this one. Okay, so using Malus Law, I equals to I naught cos squared theta. Okay, so we substitute the I here. After the Polaroid, I is half I naught. So we substitute into here. Okay, and then the I naught is the original, means intensity before the Polaroid. So it's I naught. Then cos squared theta. Okay, so we cross multiply. So we cancel out I naught. So it becomes cos squared theta equals to half. Then square root of half. So we get theta equals to 45 degrees. So angle theta must be 45 degrees for the intensity of the light to reduce to half I naught, or 50% to I naught. Okay, so any problem with this question? No, Okay, so we go to the second example. Okay, vertically polarized light with an intensity of 515 watt per meter squared passes through a polarizer oriented at an angle theta to the vertical. So find the transmitted intensity of the light for theta 10 degrees, 45 degrees, and 90 degrees. Okay, so we are going to use Malus Law again. So how to use Malus Law? I equals to I naught cos squared theta. So the question asks for the intensity. So that's mean the intensity before pass through the the second. So that's mean the second polarizer. Okay, so vertically polarized light. So that's mean the light has passed through the first filter already. So it is polarized already. So that's mean the I naught here is 515 watt. Okay. So if from here to here become half, right? But it's not. It's given it passed through the polarizer. Polarizer, the first polarizer already. So this is the polarized light. So I naught is 515 watt per meter. Then we are going to find the intensity after passing through the this polarizer. Okay, so using the equation here, we are going to find this I. So I naught is 515, substitute into here, and the angle is 10. So we get the answer 499 watt per meter squared. Okay, so next, the same equation, Malus Law. Okay, I naught still the same, 515 watt per meter squared, but the theta now become 45 degrees. Okay, so you substitute here, you get 258 watt per meter squared. So again here we found that okay, the 515 become half, the intensity become half. So you double this one, you get about 515 watt per meter squared. Okay, so for angle 45 degrees, okay, so the intensity becomes half, reduced to half. For the C, when the angle is 90 degrees, okay, when the angle is 90 degrees, so we get 0 because cos 90 is 0. Okay, so 45 means in the middle of 90 degrees, half of 90 degrees. So the angle half, the intensity also becomes half. Okay, so this is second example. Okay, the third example, okay, is a more complicated question. Okay. So in the polarization experiments shown in the sketch, the final intensity of the beam is 0.200 I naught. So that's mean in this question, the light pass through here two polarizer. Okay, the first polarizer, the second polarizer called analyzer. So what is the angle theta between the transmission axis of the analyzer and polarizer? So this is the polarizer, this is analyzer. So we are going to find the angle here theta. Okay, so as we know earlier, unpolarized light in this case is named as I naught. And then after pass through the first filter from the unpolarized light, it always reduced to half. Okay, so it's become half I naught. This is understood already. So unpolarized light, after pass through the first filter, it becomes half. Then after pass through the second analyzer, the polarized light, then we use Malus Law. Okay, Malus Law, I naught cos squared theta. But it's given already, the I is 0.200 I naught. Okay, now we are going to convert this to 3D diagram, so better to see in the 2D diagram, from 3D diagram to 2D diagram. So this is the first polarizer, this is unpolarized light. So after pass to polarizer become half I naught. Okay, even though not given in the question, but this one must be understood. Why? Unpolarized light pass to polarizer becomes half, reduced to half. Okay, then after the second polarizer, it's become 0.200 I naught. Okay, next, using the Malus law, okay, so we substitute the half I naught and 0.200 I naught here. And remember, the I naught from here, okay, so this I naught for the second analyzer now. For the second analyzer, the I naught is what? Okay, we use this one, this second analyzer. So the I, not the I naught, I is 0.200 I naught given. So therefore, the I naught must use this one, not this one, so must use half I naught. So this is where the common mistake student makes. Okay, the I naught here must come before the analyzer we are to refer to. So we are referring to this analyzer. So therefore, the I naught must get from here, half I naught. So now cancel out the I naught. So we get theta equals to 50.8 degrees. Okay, 50.8 degrees. That's the answer. Okay, any question on this question? No, Okay, the last question. I think this one is from your textbook, Okay, from your textbook. Okay, example 23.13. Okay, 3 pieces of polarizers X, Y, and Z. Okay, now we have 3 polarizer are arranged in line as shown in the figure. So the polarizing axes of the polarizers are vertical. inclined at 30 degrees, okay, the second one, to the vertical and horizontal respectively. So horizontal means 90 degrees from the first, from the vertical. So a beam of non-polarized light is directed on polarizer X. So this is the first filter. Okay, X is the first filter. So it is non-polarized. So remember what I said just now, what to be understood from non-polarized light after pass through the filter. So non-polarized light after pass through filter, it reduced to half. Okay, that's knowledge to be bear in your mind. Okay, non-polarized light pass through a filter becomes half of this light, intensity of this light. Okay, so given the intensity is I, in the diagram given I, so not I naught. So be careful of the variable given in the question. So in this case, it's not given as I naught, it's given as I. Okay, write in terms of I, not I naught, I, the intensity of the light beam transmitted by polarizer X and transmitted by polarizer Y and transmitted by polarizer Z. Okay, then question B, through what angle must polarizer Z to be rotated so that no light is transmitted to it? So we do A first. Okay, A. So from here, we are going to determine X, Y for each polarizer. For each polarizer, the intensity of the light pass through. So for the X, okay, very easy. I becomes half I. Don't use I naught because given in the question is I. Okay. So becomes half I. Okay. Number one, very easy. So now Y. So pass through Y, the first one, okay, is half I from question one, okay, half I. So we are going to use this, as I naught in the Malus Law equation, okay. So what is the intensity after pass through Y? Okay, now we use Malus Law. Okay, Malus Law. So what is this I? This I is the I2 we are going to determine. Okay, I2. Okay, I2, we are going to determine this I2. So the I naught here must use the I naught before the polarizer. So that's mean polarizer Y, before the polarizer Y. So before the polarizer Y is half I. Okay, half I. Okay, then the angle is given 30 degrees from the vertical here. So from the first polarizer, remember the angle must measure from the first polarizer. Before this polarizer like X, so it's 30 degrees. Okay, so we simplify this equation. Cos squared 30 degrees is 0.75. And then I2 is 0.375I. Okay, divide by 2, so we get 0.375I. So this is the answer for intensity of light after pass through polarizer Y. Okay, any problems on the question A2? Can, Okay, now the third polarizer Z. So we are going to determine the intensity I3. So we name this as I3. Okay, intensity of light after pass through polarizer Z. Okay, so we use the same Malus Law, I equals to I naught cos squared theta. Okay, so be careful of what we are going to substitute into. So the I here will be I3. Okay, this is what we are going to determine, I3. Okay, and then I naught, which one? I naught must substitute the I2. And we have calculated I2 already, right? So it's 0.375I. Okay, so the intensity before the polarizer. Okay, in this case is polarizer Z. So the intensity calculated in A2, okay, 0.375I. Okay, then the angle must be very careful. The angle here is angle from the initial polarizer, right? That's mean Y, not from the X. The 90 degrees is from vertical X, but the 90 degrees is after you polarize, after you incline the angle from 30 degrees. So that's mean 90 minus 30. Okay, so must be very careful. Okay, that's why the theta now becomes 60 degrees. So squared becomes 0.25. Okay, so the answer is 0.094 I. Okay, 0.094 I. Okay, any problems with 3? Okay, I hope for the question it becomes clearer for you all. How to use Malus Law, I equals to I naught cos squared theta. Okay, and the common mistake students make is always because of the where the I naught to be referred to. Okay, remember the I naught must be referred to the intensity before the polarizer. Okay, so next question B. Through what angle must polarizer Z be rotated so that no light is transmitted through it? So what is meant by no light transmitted? So if no light is transmitted through it, so this means the light the intensity of the light is 0. Okay, the meaning is the intensity of the light is 0. So for the light is 0, theta must be 90 degrees. Okay, this is understood. We have proof already from the previous slide. Okay, so theta equals to 90 degrees from example 2, if I'm not mistaken. Okay, I3 is 0 if theta is 90 degrees. Okay, so now I is 0. If you use here 0, you cannot use the cos 90 is 0, so I is 0. Okay, from this equation. Okay, then to know 90 degrees, 90 degrees here is from the polarizer Y. So this is 30 degrees. So 90 degrees, just now we rotate 90 degrees here is only 50 degrees, right? So another 40 degrees. Okay, so that's mean 90 plus 40, 30 degrees. So to rotate 90, so 90 plus 30, okay, will be 120. Okay, so let's say the angle here you rotate it 30 just now, so to be 90 degrees, so that's mean another 120 from the vertical. Okay, from the vertical, so the answer is 120 degrees to the vertical. So the 90 degrees here is from X, okay? So not from Y. So that's mean the 90 degrees for intensity to pass here become 0. The intensity becomes 0 must be measured from polarizer Y. So after rotated 30 degrees, add 90 more degrees for the intensity to pass through Z becomes 0. Okay, the Z. So it's 90 plus 30 becomes 120 degrees to the vertical.